Generative AI took the world by storm. But while this tech is truly amazing, its generative nature often results in mistakes, sometimes called hallucinations. Many companies are using retrieval-augmented generation to fix this, but there's a better way: graph RAG. Learn more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Enhancing AI accuracy with graph RAG. Here are our speakers today. Yours truly there, of course, Philip Rathle, CTO of Neo4j, Jon Brewton, CEO and co-founder of data², and Daniel Bukowski, CTO of data². Quick introductions. Philip Rathle, I've known this man for a number of years, since way back in the Embarcadero days. He's been in this business for a long, long time. Now he's working in graph. Tell us two seconds about yourself, Philip.
Yeah, I've been doing databases for a long, long time, like multiple decades. Fell in love with graphs when I discovered them about over a decade ago now. And it's just been this journey of slowly but surely, industry after industry, use case after use case, realizing that graphs are good for lots of things. Until very recently, GenAI showed up, and it turns out knowledge graphs, graph databases play a really important role there. So looking forward to speaking all about that today.
Yeah, and Jon Brewton, CEO and co-founder of data², former military guy. Tell us a bit about yourself.
Yeah, Jon Brewton. I'm a oil and gas and military and defense guy for my entire life, so that really makes up who I am. Our company, data² was founded roughly 19 months ago, and we started our company to meet a vision of creating and discovering a better way to do analytics. And one of the best ways that we found was to tie graphs to how we sort of see the world. And that led us to Neo4j and our partnership there. But we're really building an end-to-end platform that sits on top of, next to, or alongside a lot of other systems. And we built this platform, the review platform, to empower analysts and decision makers to analyze massive amounts of differentiated data, so multimodal data at its core, and help improve their strategic decision-making, their tactical decision-making. In concept, we're a lot like Palantir or C3 AI or Scale AI, but we're different in one area that sort of makes us very different. We combine graph data models, traditional data science, graph data science to deliver fully explainable, fully reliable, fully transparent, fully trustworthy outcomes. So with our system, we've been in key deployments in the government and in the commercial space in the oil and gas industry. And ultimately, we're looking to share our story with some people and tell you that there is a better way to do analytics today. We can reduce hallucinations to nothing, and we can give you real explainability in these models at scale.
And that's the key, folks. We'll talk about that through the course of the next hour. Daniel Bukowski, last but not least, tell us a bit about yourself from Neo4j to data². So you've worked with both these companies.
Absolutely. And in fact, I've been working with graphs for about 20 years. I started as an Intel analyst in government 20 years ago, building them by hand. And then when the Panama Papers were published, using a Neo4j graph database, that was my motivation to move out of kind of intelligence and forensic accounting, which is where I started, into data science, and especially graph data science, or network analysis, as we called it, about 10 years ago. Spent a couple of years at some of the big tech firms using graphs for cybersecurity, incident response, that type of work. And then, as you mentioned, spent the last few years working at Neo4j, really focused on graph data science, and as ChatGPT was released, all of the integrations with GenAI. A few months ago, I met Jon and decided to make the leap to data² because I was really excited about the platform that we were building. But even though I'm with data², we are, as evidenced by our presentation today, we're really close partners with Neo4j. We're building on the foundation of a Neo4j knowledge graph, and really thrilled to keep moving this partnership forward.
Well, we're going to do that right now. So There's the Tower of Babel. You all probably recognize this. I had an epiphany a couple weeks ago, and it's been blowing my mind ever since. I've been in this industry for 25 years, really over 30 years if you go back to the early dot-com days, or like back into the 1990s. And I've been fascinated by technology. Well, if you go back to the earliest days of programming, of compute, of information systems, what's the foundation? Well, of course, it's the database. And you have applications that sit on top of the database. You have the network to get access to things. You have security and other stuff like that. But mostly it's the database and the applications. Well, over the past half century, we have worked, and I mean we by many, many, many companies. There are like 400 databases now that you can use, or something more than that even. And we've worked to make them faster, more reliable, more durable, more performance. We've focused on greater concurrency of users, things of this nature in database analytics, all kind of stuff we've been focused on building over the last half century. But one thing has always been table stakes, and that's accuracy. We've never sacrificed accuracy. Whatever you put in the database is what you got out. It's a question of how fast you got it out, how easily you got it out, how you can get out and join with other things, for example, joins and all that kind of stuff. But accuracy has always been 100%. It's just assumed. Of course, it's going to be accurate. It's table stakes. And then what happens? A couple years ago, GenAI comes along, and it's like the Tower of Babel coming crashing down. We take accuracy and throw it right out the window because these are probabilistic systems. You can't crunch letters, you can't crunch images, but you can crunch numbers. And so these large language models, what do? You take text, you train your model by basically updating weights and biases, billions of them in these parameters, billions of them, weights and biases on vectors, basically. So cat becomes a vector, dog becomes a vector in this sort of landscape of vectors. And then upon a prompt, it converts the vectors back to text or imagery. And here you go. This was done using GenAI, using Gemini, as a matter of fact, from Google. My point is that all of a sudden, it's like throwing a noise filter on the end of the workflow. We worked so hard for 50 years to get it just right, and now let's throw that all out the window with GenAI. That's kind of what's happened, and that's crazy. So, and I was talking to a gentleman just a moment ago on a separate show, and he was saying, yeah, these big guys, they don't even know how to fix this problem. It is by nature generative AI. It's as the top go-to-market guy for OpenAI said to me on Twitter a couple of years ago, remember, these hallucinations are not a bug, they're a feature. It's generative in nature. This is what the guy's told him himself. So I point that out because it's kind of crazy. And we have to find a way to ground these things. And vectors alone aren't going to do it for you. Vectors, remember, are just representations. It's a lossy process to go from text to vectors, then from vectors back to text. It's always going to be a lossy process. So how do you ground it? Well, of course, there are vector databases. You can have a RAG model, Retrieval-Augmented Generation. We're going to talk about that. But it's not going to get you there. Even some of the best ones are like maybe up to 85%. Well, what part of your business can be wrong 15% of the time? I'll tell you what part, not much at all. All right, so with that, I'm going to hand it off to, I believe, Philip Rathle. I'm going to stop sharing. And Philip, why don't you go ahead and share and take it away? And folks, don't be shy. Send your questions in at any time. We want the hardest questions you can give these guys. So go ahead, Philip.
All right, excellent. So yeah, we've got a fun agenda for you today. We're gonna alternate between just concepts, build on the concepts, and then jump in with lots of demos interleaved in between. So let's talk about knowledge graphs first and what those are, and then that becomes a foundation for, well, how do they help with GenAI? And my teaser here is knowledge graphs showed up on Gartner's list of 30 emerging technologies that will guide your business decisions in their impact radar for 2024. I don't know if they've published the 2025 one yet, but you'll see there are two things that they're saying are important now, and that is Gen AI, no surprise there, and knowledge graphs. So pretty important technology. And if you are questioning, how you explain to your boss spending time with us today, here's a good excuse. So what's a graph and where do graphs show up? And let me start with some examples. It's here's a graph of commerce transactions, and you can picture all the kinds of use cases that might involve this kind of data set. We have a customer buying a product, another customer buys the same product, customer is at a location, gets delivered, the product has different components. This is a very simplified version, but you get the idea. Another kind of graph that you have is in product targeting. So here I have a set of products. They're grouped into different categories, and each one has a SKU, and they're tied into promotions. And those promotions actually oftentimes have a deep, deep tree of promotions by category and time and location and things being bought together and so on and so forth. Another example you see is with customer engagement. So something starts out as a lead, and then it becomes a contact, and then it moves through a funnel. And along the way, that funnel isn't just a strict top-down, straightforward kind of thing. You've got all this activity, and it shows up naturally as a graph. And then digital twin is another one, as products are composed of, you have product digital twins, city digital twins, building digital twins, and all these things have a shared characteristic of having components and subcomponents and subcomponents and subcomponents. And these nicely show up as hierarchies or graphs. In fact, many of the top airlines and car companies use Neo4j to store their entire product. So there's a digital twin of the logical architecture for a given airplane, and then each physical airplane out in the real world has a corresponding physical graph, which is its digital twin, which they can use for documentation, part replacements, impact analysis, design, and so on. So these are examples of the many kinds of data sets that you have showing up due to activity that inherently is complex, connected, dynamic. And if I boil it all up, you'll see two kinds of shapes here. One is networks. So a lot of your world as a business, as governmental organization, et cetera, shows up as networks. So here are some examples: computer networks, social networks, communication networks, biological, ecological, payment networks, transportation networks. You've seen all of these. Or hierarchies. So what do you mean by hierarchy? Org chart is a common one. Supply chain, bill of materials, I mentioned, like product and airplane graphs, promotions, asset ownership, if I want to do ultimate beneficial owner, and so on. And now if you generalize networks and hierarchies, you could say those are both different kinds of graphs. Oftentimes, you want to be able to attach these things to each other as well, and derive additional value by just connecting different parts. And you've all seen this and probably lived this many, many times as I have. The way we most commonly store networks and hierarchies is in a relational database, and it ends up looking like this. And it often takes a long time to get from your logical or conceptual design into something like this and to query it. And what a knowledge graph is, and a graph database, is simply a different abstraction for storing the same data, but not as tables, but rather as a graph. Turns out there's an ISO standard that came out last year on this, called GQL. GQL is the language that is now a sibling language to SQL. And it's the first time in close to 40 years that the International Centers Organization has deemed a data model and a language to go with it important enough to create an international standard. So this is just a way of storing data that's aligned with how we conceptualize the world. So those of you with a data modeling background, the conceptual, logical, physical model all look pretty much aligned. And one of the key things that this offers is built-in agility, because your schema is flexible. You can just add data to your graph and not have to model it ahead of time and remodel it and go through schema migrations. And in a world of AI where you've got infinite choice of the kinds of data you can bring in, and data business is fast moving, which means your data and database needs to be fast moving, and you need to be able to stitch all these things together. It turns out the graph is a really good representation for this, which is what today is about. What can you do once your data is in a graph? You can answer questions like what's important, what's unusual, what's next. One way I like to tell this is that the shape of the data tells a story, the topology tells a story, and this is another kind of insight that you can lever into your application that you're not getting if you're just looking at data from a store and retrieve perspective. I won't go through all of these, but suffice to say that there are lots of different uses of graphs across different domains. You'll see some examples. And that this is a trusted and true technology foundation that you can use. You won't be the first by any means to leverage it. And then I'll just close by pointing out some areas inside of the enterprise that are graphs. So you have your graph of employees and a bunch of use cases that are tacked onto that, where if you represent your employees as a graph, you can do better talent, learning and development, career management, skills management. We're actually working with one of the world's largest employers to create a GenAI based talent mobility graph of help me find my next role inside the company. What's the best path? Network and security. This is where Daniel came out of a while back. And there's a great saying coined by someone at Microsoft saying that attackers think in graphs, and if defenders think in tables, then they're pretty much sunk. Like you're playing checkers versus chess. Suppliers and partners, and I won't go through all the use cases. You can imagine all these process, product, and so these are all real world examples of individual data sets across your company that are graphs where you can add a lot of value. And today is about Gen AI. There's an opportunity to up level every single one of these using Gen AI with knowledge graphs. And last but not least, customer. And the other notable thing, and this is a segue into Klarna, which we'll talk about later, who recently revealed that their Gen AI application, which has allowed them to, among other things, unplug 1,200 SaaS apps and create all kinds of new top line value, is about repatriating and connecting all the data they have in their enterprise into a connected knowledge graph. So all these things connect to one another. And the beautiful thing about graphs and graph databases is you don't need to do what we used to do with data warehouses and data lakes, which is let's boil the ocean, let's bring all the data in the known universe in and then try to figure out what to do with it. You can actually flip it around and say, I'm going to start with one of these, knowing that I'm building towards this.
Yeah, just one quick one before Dan jumps in. I think the last thing that you talked about there, Philip, is so important is how do you use this stuff to create value at the end of the day? And I think a lot of people are spending time looking at sort of the shiny objects here, which is neat. We can generate text, but how do we convert that technology and the use of it in combination with graphs to something that creates value? And we'll go through it a little bit later, but like Klarna, working in the oil and gas industry, we've been able to define a couple of key use cases. And it all really starts at the end of the day with connecting information. And whenever we're able to connect information, we can get beyond what a sort of traditional approach is. And Eric talked about this earlier, a sort of a vector-based method, right? We're essentially looking at flattened relationships that are complex in how we connect them, but not persistent in nature, while a graph is very tangible in nature. So that allows us to sort of focus on the foundations. And when we can distill that down to problem spaces, we can really start to evaluate the pieces of information that are required to answer critical questions within a given problem space. Mm-hmm. We understand those things and we can start to build persistent graph objects around them. And then we can understand transactionally how information flows through the system and what is relevant to that. And as long as we can do that, we can start to develop this sort of unified knowledge stack. And it's connecting previously siloed information without having to data lake it. We can actually leave it where it is and create persistent connections to it and start to do tactical extractions from existing repositories of information, all in service of trying to optimize the value chain. And then in the oil and gas space, like I said, we'll talk about a couple of things, but we've been able to generate and unearth a lot of value very quickly by applying graphs and these techniques to commercial use cases. And Dan will give you a demonstration of what that looks like. And then we'll get into the details from an oil and gas side later. But I just wanted to say the Klarna example is incredible. And there's another set of incredible examples that we're going to stumble upon and unearth over the course of the next year that are going to be just as meaningful. And so we're really looking forward to the conversation today. Dan, sorry, turn it over to you, sir.
Yeah, absolutely. Happy to do that. And what we wanted to do is just jump in real quickly and just show what this would look like using data²'s review platform combined with the power of a Neo4j graph database. And so let me share my screen really quick. And is everything coming through?
Yep.
All right. So at data², we're building the review platform. And what this is it really takes the Neo4j database and turns it into a production-ready, enterprise-grade application. And our platform does three things that to not just help you solve those problems, a lot of like what Philip was talking about, but do so as quickly as possible. Our platform will help you get your data from the source into Neo4j label property graph. So whether you have structured or unstructured data, bring that data into the graph database. From there, you can then interact with the data using dashboards and interactive visualizations and kind of analyze your data as a graph, which standalone is an incredibly powerful capability. Something that, I know Philip knows well and I know well. It was a lot of our customers were working towards that when I was at Neo4j. But then we also add on the reasoner, which is actually what I'm showing here, which is that graph RAG. It's using the graph to inform a language model to enable accurate and highly transparent interactions with the data. And so the scenario we have here is one that's very top of mind right now. Supply chain, specifically secure supply chain. This is a synthetic data set that we created for this demo. And you can think about it from the perspective of whether you could be a program manager in the military or working at a major defense contractor to build a new drone, a new UAV. And the scenario we have is we heard that there was a malware attack on one of our suppliers. And so what I was able to do using the data² reasoner is just ask, which of my vendors or shipments or products were affected by this malware attack? This is a small data set, but you could think about it. It could be a global supply chain with hundreds of suppliers and thousands of components. When I ask the reasoner this question, it gives me, it immediately finds who was the vendor who was impacted, and then what were the shipments that we know were impacted. And what you see right here inside these parentheses is this is actually the citation back to the graph. And you will see this scattered throughout the answer. We've designed the reasoner so that everything it brings back is cited in a node or a relationship back in the knowledge graph. And it's very clearly cited so you have that transparency. So just like, I started my career as an Intel analyst, we have our bottom line up front right here. And then the reasoner will go through and give a more detailed answer around who was the vendor, what are the specific shipments, and then what were the specific products that were affected. Let me go over here. And then all throughout we have our citations, again, references that I could take back. This is an ID of a node in the graph. So I know where this answer came from. And that's what we see is so important with our customers, especially in energy, especially in defense. They want to make sure that everything is fully transparent and fully cited back to the source data and to the original conversation. You just don't get that with an out-of-the-box language model. So I'm going to step back a little bit and say, okay, how did we get here in the response? So most of the data or most of the graphs that I've built, just throughout my career started from structured data. And if I'm a supply chain officer or a program manager, I probably have a lot of tables or a lot of spreadsheets where I have my vendor and product information. That's actually what we have over here because a lot of people still need to have their data available in its native form. So if I go over here in the platform, I can see I have all of my suppliers. This would be a table in a relational database. I have all of my products and kind of components and subcomponents that are rolling up to this finished product. I have my contracts, which is a mix of structured and unstructured data. So who's contracted to deliver what? What are the terms? What are the value of those contracts? I have all of my shipments, what's in flight, what's in transit, what's delivered, what's delayed. And then we're also bringing in open source information. What are events? There's new sanctions. There's new export restrictions. We might have tariffs. Who would have thought? All of these things are going to affect a global supply chain. And then because this is a government program, we might also have intelligence, or this, if you're a commercial organization, this could be cyber threat intelligence from a kind of a feed provider. So we're bringing in all of this structured and unstructured information and turning it into a graph. And so this is kind of the starting point of taking your data from where it's at and getting it into that graph. But what does that look like? So the next thing we have as part of the platform are the key graphs. And this is a series of dashboards that we've built to show just different kind of limited views, because you might not need a fully interactive experience with the graph. You might just need some quick just dashboards like you would have from any other platform. And so, what we see right here is actually the graph data model. It's what does my data look like as an actual graph? And we're using part of the Neo4j platform here where you can see I have organizations. These are my suppliers. I have the shipments. I have the intelligence. I have the products and components. And then this is just giving you an overview of what is actually in this database, what is in my graph, the nodes, the node labels, and then what are some of the key patterns I should be aware of. An organization produces a product, a supplier produces a component, these types of things. But then we can start going a little bit further and really show the power of viewing your data as a graph rather than in a spreadsheet. So if I click over here, I actually have, and let me get zoom out of the way. I actually have my entire component graph. This is what Philip was talking about before, where you might have all these different components that roll up in a supply chain to a final product. I'm seeing that here. Obviously, this is a very small, small demo data set, but I have my drone in the middle here, and I can start to see what are all the different components that come together to make this finished product. And obviously, there's maybe 24 here on the screen. This could easily be 10,000 or more components for a sophisticated drone, and I can start to see, what exactly, what is each piece of the component coming together, and what subcomponents feed larger components and make up this actual product. Now, assuming we have a really large supply chain, I might just want to look at a specific piece of this. So I can actually zoom into just a small piece of the product if I want to go a little bit deeper. Again, these are just small views into the data. We can see a 360-degree view of our suppliers. Again, I have one of my prime suppliers here, and I can start to see what are the products they're building, or what contracts do we have, what intelligence, what shipments do we have about them. Very useful when I just need to get into a specific part of a large, sprawling global supply chain. We can do the same with shipments. And then also we brought in our intelligence. And so again, I have a cyber threat bulletin here. If I want to see what's going on, I'll zoom in a little bit here if I can. I actually have, this is a threat advisory about some malware that we were worried about in our supply chain. That's exactly what happened and actually disrupted several shipments from a key logistics provider.
Wow.
So let me zoom out here. It's actually not cooperating with me. I'm a little stuck on my screen right here.
That's quite all right. That's quite all right. I mean,
Yeah.
this is absolutely fascinating. And what I love about this is your ability to drill left, right, up,
Yeah.
down, back, sideways, and just move all through this because you've synthesized a whole array of information systems. I mean, you think about it, we came up with data warehousing because we realized that you couldn't really query operational systems very well. It's not what they were designed to do, but it's all structured data. Well,
Yeah.
all the context is in the unstructured data, and unstructured data doesn't necessarily fit into relational tables. And I think that's
Yeah.
the key. So now what you're doing is you're fusing together, you're synthesizing this array of information tools to give a truly strategic bird's eye view of everything that's happening, right, Daniel?
Exactly.